I'm very pleased to welcome you all to today's talk about dirty trenches and clean code at OXG. OXG is a new telecommunication company that was founded 2.5 years ago. In this talk, Ralf and Hendrik will share how a young company aiming for a cloud-first strategy encountered some obstacles when incorporating not-so-cloud-native third-party systems. After beginning his career in the automotive industry, Ralf transitioned to telecommunications, where he built software to automate processes for cable customers. At OXG, he establishes a greenfield telco IT landscape, and now he leads IT architecture and cloud governance. Hendrik is a principal consultant at TNG. Leveraging his extensive expertise in software development and system integration, he spearheaded the development of the prototype for the main integration layer. He was one of the earliest contributors at OXG, and now he serves as product owner. Both Ralf and Hendrik have shaped numerous architectural decisions regarding third-party integrations and system design. We're delighted to have you both here as speakers today. If you have any questions, feel free to raise your hand and ask your questions during the talk. And now I'm looking very much forward to your talk, and I'm sure that will gain valuable insights from OXG's cloud-first strategy.
Thanks a lot. Thanks, Sonia. There were rumors that said cloud first or cloud only is not possible for a telco operator, and we tried to prove different. So in the following talk, we'll explain you a little bit about what OXG is, what the idea behind and the strategy is. Then we tell you a little bit more about what deployment is, network deployment, not only software deployment, and how we did integrate software. And also there's the part now as we're live, moving towards production, how this went, and the learnings we took during the last 2.5 years. So going a bit into the German telco market, it's mainly driven by DSL subscriptions, roughly 25 million, 9 million cable subscription, and a lower number, 5 million fiber subscriptions. And Vodafone decided to improve or extend its market by building fiber, and decided to partner in a joint venture with Altice. And together with Altice, they founded OXG in 2023 to build a fiber network, modernize existing cable network, and also increase the footprint in urban areas with a fiber proposition. The name OXG stands for, and it only makes sense in real Denglish, Open Access Glasfaser, meaning that we build an open access network. So we do a B2B model addressing resellers to sell our fiber connectivity as an internet bundle. And now Hendrik is going to explain a little bit about the surroundings and how it's set up.
On the business strategy, so to say, yes. OXG is the green box in the middle, and OXG plans and builds a GPON fiber network. GPON stands for Gigabit-Ready Passive Optical Network. We built this network and provide the last mile from the curb to the customers. For that, OXG invests about 7 billion euros over the next decade. This is financed by the two shareholders, Vodafone and Altice Labs on the left. And on the right side, you see the customers of OXG. The customers are access OXG through a standard interface, Esprit, which is the standard in the German market. Our customers essentially are big resellers. So you probably know Vodafone and 1&1, I'm pretty sure. Those are fairly self-explanatory. But there's also Vitro Connect. That's an aggregator, aggregating smaller resellers into one OXG customer. They do that because smaller customers may not want to implement the Esprit interface themselves. But there's also smaller ones we directly integrate, like Bahnhof Internet, which is yet to come in the future. So now, if these are our customers, what is our product? Our product is pure bitstream access. We do not sell any high-level services. We sell just the service, the bitstream service. We hand over the traffic from the GPON network to the transport network, which is provided by Vodafone, and they also hand this over at some higher level to backbones of specific resellers. So our product does not include things like voice over IP or video on demand. Like I said, we only provide the bitstream access, so it's essentially described by the bandwidth. That's the main feature of our products. We only have a very small, limited palette of products. One extra bit is whether or not we attach an ONT to the individual line, and we'll have a look at that on the next slide. So here you see a schematic of the network we're building. On the very left side, the two yellow small boxes, those are the OLTs, that's optical line termination. Those are essentially the gray boxes you see in the streets. That's the point where traffic is handed over to the transport net. That's one end of OXG's network, so to say. To these boxes, you can attach roughly 4,000 households. It's not entirely true, but let's stick with that. 4,000 households, but you do not want to run 4,000 cables to these boxes. So in the middle, like there, we have so-called passive distribution points, which are essentially optical prisms. They split the cables in 32-fold, so that the number of cables running to the OLTs is reduced by this factor. From the PDPs, it goes on to the hoops. That's these things right down here. Those are small boxes in the basements of the houses, and from there on, cables are run to the individual apartments, terminating in wall sockets where users can plug in their ONT. The ONT is the optical network terminal, and at that point, the optical signal is translated to an electrical signal. And the question of whether or not this ONT is provided by OXG itself or by the customer or the reseller, this is the second dimension I mentioned earlier. So either we provide a PON product without the ONT or an ETH product with the ONT. And that's an overview of what the network looks like. And like I said, the G stands for gigabit ready.
So making the gap back, closing the gap back to our title, OXG right at the beginning decided to do a cloud-only strategy. So not to own any hardware, and we decided for two providers. One is AWS, and the other is Microsoft 365 services for Office-related stuff. And when you talk about the telco, you usually have two main domains where you settle your applications. One is the business support system, everything supporting the business or facing the customer, and the others are the OSS systems, so everything that's happening in the network and closing the gap to the business systems. And our main approach is so anything that differentiates us in the market, we do ourselves. So there's the wholesale interface we have towards the reseller. We have the process orchestration that is happening to implement all the business processes, like activating new customers, terminating existing customers, changing their bandwidth, or even taking care of tickets or issues that happen in the network. And of course, we have a face to the customer on the website. For instance, the direct phase we have is when we want to build out in the homes, we need the permission of the property owner. And that's one of the things you can do on our website on mitmachen@oxg.de to give your permission that we can offer the service. And the other aspect is wherever we have something industry specific, we buy it as a ready-to-use software and adapt it to our needs. That's mainly happening in the OSS systems, where we have an inventory system from LTs, we have monitoring, we have fulfillment, like doing the actual activation in the network. We have systems that measure the network performance, so we see where things are degrading or not working optimal, and of course alarming. And another thing that's very, very close to network is the element management systems that are those managing the OLTs Hendrik managed that are inside the street cabinets and connect, for instance, 4,000 customers in a city area. And especially in that area, it was said you can't run that EMS in cloud. It needs highest, very, very low latency. It's not possible to do that. And yes, it is. It works. So that's finally one learning we took. Just do it and try it out. And rumors are not true always. And things where we say we just need them, we don't have any special requirements. We just say we buy them as a managed service if they're available. Things like ticketing or CRM system, and also things we use in our daily work, Jira and Confluence from Atlassian or GitHub for running our CI/CD. And I said we don't own any hardware. That's not 100% true. We own the hardware that's on the streets. We own the cables that's sticked into the ground. And we need to connect to that somehow from the cloud to the real curb. And that's why we have a fiber link from Amazon in their data center to the handover points at Vodafone in the backbone. And now let's talk a little bit about deployment. Most of you know it as software deployment. We spend 7 billion euros and in deployment of hardware, cables, digging up streets and restoring the surfaces. And I brought some interesting aspects. So one part of the deployment is planning the network. And planning a network in Germany means digging it underground, not doing aerial installation, which are much cheaper. And this special requirement had one challenge. The inventory systems we are using, they needed to be adapted a little bit to this German way of blowing fiber cables into ducts underground. And as a result of that, we need to document the exact location. Because if you do a cable from a pole to the house, you can see it. If it's underground, it's hidden, and you need to know where it is. And that's why our main inventory system has everything. It has the geo information, like city borders, streets, addresses, everything. And on top of that, we include the physical and the logical inventory. So we need the physical inventory to do our actual work on the network, and we need the logical inventory to know where things are and how we can connect from the backbone to the final customer. That's an inside view of a street cabinet. So most of the operators do build them to their custom requirements. What you can see is you have the power supply. That's the last power supply in the network. Then you have optical splitters. And then you have the rack space where the fiber router, the OLT, is going. And you can also see backup power so the whole system runs even in case of power loss. That's a place which you can see for a couple of days in front of your house. So every single household has own duct where we blow in the fiber, and there's this orange thing is called the duct bundle, and at every house we just cut one of those pipes, ducts, and do a junction to the household. And interestingly, as I said, we want to do exact documentation. We also make photos of each of those junctions. And challenges we have is like that when on site they do the documentation, you can see that this pipe that has been cut here is originally blue, but the camera of the one who took the photo made it turquoise. So it's even hard to have a good documentation if things are AA tempered before they are stored as a picture. Another thing, it's not ideal, but if you don't give permission as a property owner that we can build into your house, we just build this junction, maybe 10 centimeters underground on your property, and place a so-called ball marker, and we just put the ground over it again, and when we later want to connect your house, we can find the junction easily. And so building fiber underground is expensive, and how expensive is mainly depends on what surface type you have. So cheap surface type to restore is simple tiles. A little bit more expensive is asphalt, and then come like mosaic tiles or other special, especially in older inner cities, it needs to be reconstructed very, very, very well. And one of those most expensive are these Schweinebauchplatten or bacon tiles. They're called like that because they have an uneven bottom, and when you lay out them again, each tile needs an individually crafted bed, so it's at the end flat on the surface. And yeah, that's some of the challenges you have when you deploy a network physically. But now let's get back to deploying and integrating software. I mentioned we have an inventory system, and I think it's one of the cornerstones of our IT landscape, and it includes everything we need to know about our network. So it's our main asset. Around that, we have element managers that do connect to the nodes on the network. We have workforce, so we can plan and assign where we need to build and fix things. We have a layer that activates customers and all the other helpful systems, diagnosis, ticketing, alarming, and performance. Now back to you.
Thanks. So what Ralph described is the lower part, the green part, which is called the operating support system. This essentially does the hard work administration of the network itself. On top of that, in the red and blue boxes here, we have the business support system. The business support system in the telco business usually has the tasks of administration of non-network data, customer management, and process orchestration. Now, in the specific case of OXG, the non-network data, that's essentially the permissions I've talked about earlier. We need to have a permission from the land property owners to be able to build on their property. And those are stored in the data platform in our case. The customer management is a small part of the BPO, but it's not that relevant because, like we said earlier, we only have a few customers. There's not much to do about billing and charging and stuff like that. But still, we do write bills. And on the top right, there's the BPO, the Business Process Orchestrator. This was the component built by TNG. The business process orchestrator does what its name suggests. It orchestrates the business processes. So on the top right, you see the Esprit interface, which is the inbound interface for the resellers who order a new line or order a fault clearing through that interface. The BPO accepts that call and makes calls to the underlying OSS systems with all proprietary interfaces, orchestrates this and implements the specific build-out logic that OXG set up, and then returns the call to the reseller. That's the generic tech stack at OXG. So now the green part, the OSS, those are all kind of mature systems. They have been developed for quite some time, and they can be deployed to the cloud, but it's not that easy to deploy them regularly and have them implement fixes quickly. That's why we chose the BPO to be a cloud-native service. We specifically tried to be able to deploy very quickly so that all customizations, bugs, changes, whatever which come up in the process can be kind of encapsulated in the BPO and be rolled out quickly without the need to fix everything in the low level. Right. So then let's have a look what we did when we moved towards production. Now, it's not exactly a secret anymore that software should be tested before you deploy it to production. This is true for almost all software. And most of you are familiar with this concept of unit tests, integration tests, and end-to-end tests. Now, if you've ever written a test yourself, you know that testing becomes increasingly more complicated the more complex the test setup is, obviously. If you have a test setup which is close to reality and integrates a lot of stuff, it's quite hard to set this up properly. And this is especially true for fiber cable build-out, because fiber cable build-out comes with processes which are meant to be done only once. You only put the cable into the ground once, and it's not going to be removed in our lifetime, at least hopefully not. But integrating these specifics of fiber cable build-out into the end-to-end tests proved to be quite difficult. Like I said, the software didn't even have the functionality to remove entities from the database once you had set up and run the test. So one of the teams in the BPO did a great job kind of reverse engineering GUI APIs and finding a way to then in the end do run tests. But when we started with the end-to-end test, or with the automation of the end-to-end tests, there were a lot of skeptical voices saying, well, we need to test this only twice or 3 times or whatever. Is it really worth automating? I don't know the exact numbers, but it was not a couple of times they have been run. It was closer to a couple of 100 times they have been run until now. And so it was really worth the effort having those tests automated, even if it was quite difficult at the beginning. Okay, so, and when we were done with the end-to-end tests, we were ready to launch, right? Well, we'd smuggled the dinosaur into the spaceship, but there was still the friendly user test. The friendly user test is done by the reseller. We wanted to integrate the reseller at that point and have them test our integration so that they could actually confirm that an order went through. And I remember the first calls where like 30 people were in the call and were eager to know if things had worked out. And well, of course, the first couple of tests failed, but then it was quite successful. In the end, we were quite happy with how things went. The first ONT we installed was an ONT in a lab somewhere, and it was, I think it was November 2012 2024 that this had worked. After that, we installed 5 ONTs in the canteen of OXG. So it's probably by now the best connected canteen in Germany. And well, that worked out too. But those are fairly clinical situations. I mean, an ONT in the lab does not require much deployment, and OXG as friendly customer of itself is not that hard. The hard part is, like I've said, adjusting to all the different deployment situations to scale the deployment process itself. But with the IT part of things, we were quite happy. Things actually had worked mostly as we wanted. But over the last 2.5 years, we, of course, had a few learnings. And that's what the next slides are going to be about. So let's talk about the learnings we took from this strategy. Now, this is the result of the load test of the BPO. Part of the choice of cloud native was to be able to scale quickly to the needs of OXG. We were not sure 2.5 years ago how quickly orders would be coming in and what we would have to do with those. So we needed an architecture which was able to scale quickly and very flexibly to what was coming. For that, we chose a serverless architecture in the BPO. That is, we do not have a whole artifact, not a whole thing we deploy somewhere, but we only have small pieces of code, small individual pieces of code, which take something from the database and write something to the database, or queues, or whatever, but only very small pieces. They themselves are stateless. They don't pass state around in the application. They are only small pieces, and they are like I said, stateless when they themselves are stateless. So it was quite easy to scale this kind of software. You just have multiple instances of these so-called lambdas in AWS, which run the code in parallel. And when we did the first load tests, it actually surprised me a bit that it almost worked as we had theoretically expected. There was one performance bottleneck at the beginning, which could be fixed relatively easily. And after that, the behavior of the whole system was bound by the throughput of the database. Well, that's exactly what you expect. If you have code taking stuff from database and writing to the database, that's what you expect, where it ends, if you scale the middle part as far as you can. Right. So then there's
another
security
thing we planned and wanted to really do, besides going cloud only and serverless in the BPO area, was to do secure by design right from the beginning. And that has different aspects. One is that we decided to do close collaboration between the teams. So we had teams delivering the OSS software. They had their ready products, but did their customizations in our layer. We had the BPO team, we had the website team, and we decided to do early designs, including security into their designs. And what helped us a lot there was that we focused on like predefined patterns you find in the cloud and make use of it as much as possible to keep things simple. And one decision I don't regret and was like nowadays much easier than maybe 10 or 15 years ago, go single sign-on with every application. So wherever you have a sign-in, where you have a user, don't implement a separate user database and do a single sign-on with, in our case, it is Microsoft Entra, and you have a second factor for free, especially if you go in the cloud. Many things are in the internet and not in a hidden data center. So that helped easy a lot. And one thing that's going to evolve further is that more security even means more comfort. For instance, introducing UV keys. It was like a proof of concept lasting half an afternoon, and after that deciding to turn it on for more and more users. One thing we also did was looking for a partner that has the hacking expertise or the pen testing or the security review expertise, and taking a white box look or even a black box on our applications. And not to do that at the end when you say, okay, now we're ready with the software and we want to launch it, let's do some security testing. So we did it more in the middle and towards the end, another one. And it proved right to do that. So when you start installing and bringing things on the cloud that usually run on a older legacy JBoss container, or like handcrafted pods that were usually run on Kubernetes in a data center, when you bring them in the cloud and have different opportunities to do security, you also want to test that they are working like you expect. And that's why I say, even if you have existing software that said, we use this for 10 years now, it's safe, you should also align it to what our security requirements are. And another thing that I think helped teams speed up and focus on what they need to deliver for business functionality was taking away authentication and authorization from them. So in an AWS setup, you can perfectly separate that with the teams write their policy. It's a simple attachment to their artifacts that says who can call it, what can they do. And on the other hand, do central authentication in one place and take away the burden from the teams to rethink and implement that over and over again. And one of the things you can do for free, but you must do it, is going passwordless. So the company I was before at Vodafone, we had many things in the data center, and it means if you want to have services communicate with each other, they need passwords. And if you fully enroll to what an IAM system from AWS offers, you can get away from using passwords. It's just like your train ticket on a train together with your passport. There's no secret you have with you. It's just a signed ticket and an identity, and we're applying that same principle wherever we communicate between services, etc. And also when you're working in the cloud, you need to integrate external systems like SAP or Salesforce or any other, and you can make use of the cryptographic possibilities you have with MTLS. So they tell you where the call comes from and who it is. So that can't be tampered, because most of the other providers in the cloud, they keep the private key secret, so you always know that one hasn't been leaked, and you know the request that is coming is legit. And also integrating OIDC and SAML with web applications is kind of the two options we use and recommend. And another path we went for improving our auditability is ditching SSH. So saying SSH is not allowed. Whenever there is a login to a system, we want to have an audit trail and CloudTrail. And the ideal choice for that is using Amazon's SSM service, which whenever you sign in, you do it through a personal identity and not through a key that could be leaked again. And the fun part, all of that was fun actually, but the most fun part I learned, which you can do differently, is don't do checklists on security and non-functional requirements. Play card games with the teams and foster like mutual exchange, starting a dialogue. It helps much better on focusing what the real challenges are. Are they a threat? Can they be improved? How can we improve that? It's fruitful discussions, and the result is you feel like we did the right things and not focused on just making check marks on a list. And diving a bit deeper into authentication and integration, we have single sign-on with Microsoft's Entra everywhere, and kind of advice, do not compromise. So whenever someone says, we have our own user database, no, just try to connect it, and you either use SAML or OIDC. And one pitfall we stepped in, and which is kind of learning, sooner or later you will need SCIM. SCIM is a provisioning protocol. That means whenever something, a user is created or has its permissions changed or is deactivated, that action is provisioned into other systems. So one example scenario where it helps is when you onboard a new technician, those person gets an account, but maybe only logs into the system 2 weeks later. But that means until those 2 weeks, he cannot get tasks assigned or being seen in the system. And SCIM helps making that user visible earlier. And also for the same case, if that person leaves the company and has tasks and things assigned to do, they must be de-assigned. And SCIM helps helps systems knowing that those users are not available anymore. And the important part at this is not every identity provider does SCIM perfectly. So definitely you will need SCIM, and also take how they implement and use SCIM into account when choosing an identity provider. And we talked a lot about user accounts. Let's talk about systems communicating with each other. There's the easy path to implement. So doing OAuth with client ID and secrets, spreading secrets and passwords everywhere, or even doing something in the cloud, which easily available is access keys with AWS. But both have the risk of getting leaked, and if you don't do any other protection, you open up your cloud infrastructure to data leakage. And one thing that's time-consuming and annoying is rotating passwords all the time. And the initial approach, we said, yeah, okay, then let's go passwordless with Amazon IAM and just use that. And it proved it's not easy, it's ambitious, because it's not everybody speaks AWS IAM, especially if you connect with third parties. So you will discover that you have GitHub runners using OIDC. You have to carefully configure how these policies are set up. So for instance, that you properly separate production from non-production deployments. SSM instead of SSH everywhere. It's a challenge telling established systems not to use SSH for observability, not to using SSH in Ansible, and getting rid of that it's worth it, but it's a challenge. And then we discovered that one of the major cloud providers for SAP itself, they can integrate S3, which we use in a lot of places to exchange data, but they just do access keys. And that's what we didn't want to do. So we had quite a way to go with our integration partner to make the SAP suite use MTLS. But now we have a solution for that, and also have the security that everything that's coming and flowing of data from our systems comes from our SAP instance and is not leaked or fake data because of lost access keys. And an interesting anecdote is SAP has for that purpose a cloud connector, which is meant to connect on-premise to the cloud, to the SAP cloud, but we use it to connect the Amazon cloud to the SAP cloud. And then there are third parties that say, yeah, we can only do OAuth. We don't use that modern stuff. So you have to find a way to make modern OAuth working with IP allow lists. And we implemented a gateway with Cognito at that point. And one of the highlights that we didn't take in account is a neat integration between Salesforce and Amazon's IAM. They use IAM roles anywhere, which is basically a certificate-based way of signing API requests. And it's from technical perspective and usability, the most perfect solution, because there is no need to exchange any secret data, but systems at the end can connect securely. And like the talk before said, cloud is easy, but it's expensive. No, it's not that expensive if you do it right. But to give you an understanding, when cloud can be expensive and when cloud is not expensive is when you take a look at our OSS, it consumes most of our costs. One reason is it's a bigger set of applications, but the other is it's a very classic, old-fashioned way of using EKS by just deploying nodes after nodes or pods after pods, and we need a lot of nodes to do that. And computing power that's available 24/7 has to be paid on demand to Amazon, like the full day. And we invested quite some time in shutting down environments during night, at weekends, making them smaller, especially for in the non-production environments where we don't need the power. And on the other applications where we had the chance to implement it ourselves and go serverless, you can see that they share not even half of what we do with a classical EKS workload. Yeah, and learnings from that are, one argument we heard is if you do serverless, you log into the cloud provider too much. I think we didn't do that. For instance, the BPO, the wholesale interface is modularized well enough that we can make it run in any of the other cloud providers or wrap it in on-premise containers whenever we have the need for it. Imagine for it like if you decide for a framework like Camunda, or if you decide for JBoss or WebSphere, you also have some kind of login. And that login is similar or can be compared to what we have with step functions from Amazon. Serverless is fundamentally cheaper. So it's surprisingly cheap and scales very well together with the costs. So when you don't need it, you don't need to pay much. And when you need the performance, of course you need to pay it, but the unused time covers it. And one of the big discoveries, but not one of the big surprises, is Oracle is always the most expensive option. And interestingly, if you switch to Oracle Enterprise and you need RDS support and open a ticket with Amazon, they say, yeah, for that case, you have a support contract with Oracle. Talk to them. Apps running in Kubernetes, not by default, are scalable. So they need to be designed for it. And that's one point where we work at the moment to get a better scalability in the OSS. That also means touching the design of the applications and being dependent on the one who delivers the application. And Running data center apps, even those that say we need 1 millisecond latency, it's possible in the cloud and works pretty well. And yeah, and an EKS cluster, you saw the iceberg in the previous talk. We don't do the underwater thing with EKS, but even the parts above the water level, it's still labor intensive, needs maintenance and operation.
Yeah, and then came launch. Of course, we had deployed our software to production before, and we had run the E2E tests and the friendly user tests already on production. But in September, so only 4 to 6 weeks ago, we had the full footprint launch, meaning that we released the first 1 million of addresses to be ordered from. Of course, when you do have a footprint like that, you kind of worry a bit before doing that. You did the tests, you did the non-functional tests like load tests, but still you don't know what happens if there are orders coming in, 500 a day or whatever. Have you thought of everything? Is everything working? And we worried whether we need on-call services for the first days or even longer. And then came this day, and it felt like very anticlimactic because nothing happened. It just worked, and it's been doing
orders
since.
happened, but they didn't run on problems, right?
There are of course some minor things here and there which need to be fixed, but nothing really major. So we were essentially very relieved and a tiny bit disappointed that nothing really happened, but but essentially relieved. So if you now like to order fiber cables yourself and see whether or not your house or apartment will be built out, you can check out mitmachen OXG.de. And if you're interested in building a fiber company yourself, then talk to us. Thanks a lot.
Thank you, Ralf and Hendrik, for this very interesting talk and for sharing all your insights and learnings. Are there any questions from the audience?
So thank you for the nice talk. Question with a growing focus, you just answered it a little bit, but the growing focus of data and cloud sovereignty. Is there any strategy to tackle this issue? And is it even possible with our providers in Europe at the moment?
We talked about switching to the Amazon Sovereign Cloud as an option and decided not to think about it at the moment. We have busier things to solve. Referring to what happened this week on Monday, it luckily went past by us. There are a few things we need to solve. For instance, one of our QuickSight application, the BI dashboards, they didn't work for login. If you were in it, you could continue to work, but login was blocked. But still figuring out why we have a dependency on US East here. So such things start the talks about, is it the right choice, depending on a major cloud provider, but still think yes, because it keeps things simple, and that was kind of objective to keep it simple. And when we take a look at how our IT team looks like, it could be much bigger if we didn't do cloud.
First of all, thank you for your talk, and it looks like nice and cool journey. So congratulations that you have not, all of a sudden failed with something on the start, because I have experienced it like this. But anyway, my question is, you already have Entra, right? So you leverage Azure. Like, why was AWS a solution of choice for your cloud provider? And second part, it's data lake. I think you're using Kinesis, right? And for me, it's more or less the vendor lock comparing to everything else that is scalable. So have you faced any challenges so far, and or you pretty much enjoying, and how you could elaborate on the if you want to move to the other solution or premises one to replace the Kinesis, if it's a Kinesis for the data lake. Thank you.
OXG started as a startup, and one of the ideas was don't challenge everything to perfection and just do things. So one decision was to use AWS right from the beginning, not challenge very much, and to my positive, I think it's one of the most mature cloud providers. I wouldn't not challenge that at the moment still. So I'm just happy we are a single cloud and don't need to do multi-cloud. It adds complexity we don't need. And yeah.
Maybe for the Kinesis bit, yes, in the data lake stack we do use Kinesis. I'm not really working in that area, so I don't know the stack too well. But we had some discussions in the beginning whether or not to use this, and it felt, well, one choice of others. So it is relatively easy replaceable in the context in which we use it. I wouldn't be afraid of that, actually, at that point.
Okay, so is there another last question?
I actually have two. One small one that is for the serverless thing. How much is your base traffic? So would you also recommend serverless for a user-heavy application that has a lot of base traffic? And the other one, I already forgot. It's always. Let me think. Yeah, that was for the IAM, because I don't know. Like, we use OAuth. I don't know the other thing. I have to look it up. But it's an organizational question. So how did you get this new IAM solution into existing business units that you manage? So did you inject your knowledge by going into them and implementing a small layer that does the new IAM solution?
Let's stay at the small layer. So for the Kubernetes-based workloads, we wrote a layer that they can use services in the Kubernetes to map to IAM roles, and in a result of that, they can use the Amazon mechanisms to authenticate from pods that don't need passwords then, obviously. And yeah, the first question was regarding traffic costs. At the moment, we are depending on where you look at, but in production, we are at roughly $1,000 per month in traffic. And that's the point where I think it will increase the more we deploy and the more usage we get. But actually, it's neglectable what we have at the moment.
Maybe for the serverless part, of course, this is kind of part of the service of AWS, that they scale for you and adjust to the specific profile. So if you already know your profile, it might in some cases actually be cheaper to implement that yourself. But serverless also has other advantages. Like from the architectural point of view, you force the developers to very consciously think about what input data they have and what output data they have, and don't pass state around in the application, which is a common source of bugs, actually. And for the deployment bit, we had that at a couple of points where we replaced one single Lambda. This deployment works quite quickly, as opposed to replacing a whole artifact, which, I don't know, might even take a half an hour or something.
Something to add, you don't know in advance exactly what something costs, but you usually do simple proof of concepts, how it works, and then the math of scaling that up and knowing how big the usage numbers are. It's just a simple multiplication to know what the cost will be then.
Thank you for all your questions. If there are more, feel free to reach out and ask them during the coffee break that we have now. Thanks for joining this session. I wish you enjoy the rest of the Big Tech Day, and give a last applause to the speakers.